Hello everyone. I am glad to share our work on vision and language navigation. This work provides us with insights into how to learn vision and language navigation from YouTube. First, I'd like to introduce the background of vision and language navigation, id est, VLN. In this task, an agent is required to follow an instruction to navigate in an indoor 3D environment. Some existing works learn the agents on simulated navigation environments and manual labeled data. However, training on simulated datasets is limited to a restricted number of environments. To address this, the other works seek to construct path instruction pairs by using web image data. This, however, still suffers from confused layouts and ambiguous actions. In addition, existing pre-training methods also ignore the learning of the agent's layout reasoning ability, which can improve the agent's exploration efficiency. Fortunately, we notice that there are massive house tour videos on YouTube providing real navigation experiences and abundant layout information, but are still underexplored. Inspired by this, we could obtain more diverse environments, real layout information, and native internode actions from this type of videos. So the question is, how can we learn VLN from YouTube house touring videos? To achieve this, we have to tackle the following challenges. 1. How to determine the locations of trajectory nodes and represent the visual content. And 2. Acquire matching instruction on the generated trajectory, since each video consists of unlabeled redundant frames. Moreover, we also need to consider how to learn layout reasoning ability from real navigation experience. To cope with these challenges, we first propose an entropy-based trajectory generation method to generate VLN-like trajectories. Then, we offer an action-aware instruction generation method to generate matching instructions. Finally, we devise a self-supervised pretext task to learn an agent to reason environment layouts. Given a YouTube house tour video, we will generate a high-quality navigation trajectory and its matching instruction. We use all the trajectories and instructions to build a VLN pre-training dataset, which we name YouTube VLN. Specifically, in the entropy-based trajectory generation method, we first perform sparse sampling and filtering on the video, and then we use the clip model to calculate the category probability of each frame given common room types as candidates for prompt. Each frame is classified into its own room type based on class probabilities. We combine frames that are temporally consecutive and belong to the same house category as a group. We then propose to select an image with the lowest classification Shannon entropy in each group as the key frame to represent the current view of a node. We merge the adjacent consecutive images of the key frame in the group. The feature of the merged frame is used to represent the visual content of a node. In this way, we obtain multiple nodes from a video. Next, we randomly and continuously sample several nodes to form a trajectory and use our proposed action-aware instruction generation method to generate its matching instruction. Specifically, we train an inverse model on a labeled dataset, where the input is the vision features of two nodes and the output is their transition action. We then perform inference on the inverse model for the pairwise key nodes to obtain transition actions. We also use the clip model to obtain the room type of each node. Finally, we hollowed out an existing manually labeled instruction, dug out nouns and verbs, filled in the previously generated actions and room types according to a prior rule, and then generated a correct instruction that matched the trajectory. The trajectories we generated from YouTube videos gave agents real layout information. So how should agents learn to reason about layout from them? We come up with that humans judge whether a trajectory is reasonable by reasoning about the layout of a trajectory. Then, when an agent can judge whether a trajectory is reasonable, it should learn to reason about the layout. To this end, we propose trajectory judgment pretext task to ask the agent to identify reasonable navigation trajectories. The input could be a reasonable trajectory generated by our method mentioned before, or an unreasonable one by shuffling. We finally pre-train the agent using our proposed trajectory judgment task, additionally combining it with 3 other existing pretext tasks on our YouTube VLN dataset. After pre-training, we then adapt the pre-trained model to downstream VLN tasks. We ablate our proposed modules on the R2R benchmark. The results suggest that each module brings positive improvement. We compare our agent with state-of-the-art methods on both R2R and Reverie benchmarks. Compared to DUET, our agent achieves 2% and 3% improvements with respect to success rate on the val unseen split and test unseen split on R2R, respectively. Besides, on Reverie, although our objective is solely navigation, we still achieve comparable performance on grounding metrics and even slightly outstrip DUET on most metrics. The above is the entire introduction of our paper. Thank you for listening.